we're going to look at the last 7 of our properties, and I call these properties the common sense properties because they just make sense. The first one's called the reflexive property. It says any number is equal to itself. 12 equals 12, 20 equals 20, 36 equals 36. Pretty straightforward. Doesn't even require much thinking. The hardest part is remembering that it's called the reflexive property. In mathematical notation using symbols, we would write A equals A. Another simple property is the symmetric property. The symmetric property you've used before. You've solved equations and come up with 5 equals x. And then you've rewritten it x equals 5. The symmetric property says that if you have an equation, you can just flip it around the equals sign, no problem. So in symbols, we say if A equals B, then B equals A. You can write it both ways. The third property takes us right back to elementary school. It's the zero property of multiplication. Any number times 0 equals 0. 12 times 0, 0. 18 times 0, 0. 10 million times 0, 0. In symbolic notation, A times 0 equals 0. Any number times 0 equals 0. The next 2 properties are called identity properties. The first identity property is for addition. It says any number plus 0 equals that number. 12 plus 0 equals 12. 20 plus 0 equals 20. 45 plus 0 equals 45. You can add 0 to any number you want, and the answer is not changed. You come up with the same number. The number 0 is called the additive identity element, the identity element, because it's what you can add to a number as many times as you want, and things are left unchanged. Symbolic notation, A plus 0 equals A. Now we also have an identity property for multiplication. What do we do to leave things unchanged in multiplication? Well, we multiply by 1. The identity property of multiplication says you can multiply any number by 1 and your answer is the number. 32 times 1 equals 32. 87 times 1 equals 87. 45 times 1 equals 45. A times 1 equals A. The number 1 is called the multiplicative identity element. Multiplicative meaning multiplication, identity meaning what you can do it over and over and things don't change. You can multiply by the number 1 all day long. So 1 is the multiplicative identity element. The last property, we have 2 parts to, the inverse property. There's an inverse property of addition and an inverse property of multiplication. The inverse property simply says, how do you undo something? So in addition, if I have 12, to undo it, I subtract 12. If I have negative 10, I add 10. I just add the opposite. Every number has an opposite, so when you add them together, the sum comes up to be 0. 15 plus negative 15 equals 0. 15 and negative 15 are additive inverses. Negative pi plus pi equals 0. Pi and negative pi are additive inverses. In symbolic notation, we have A plus negative A equals 0. A and negative A are additive inverses. In multiplication, we also have an inverse. We can undo anything in multiplication by multiplying by the reciprocal. For example, 3 times 1/3 equals 1. 4/5 times 5/4 equals 1. There's always 2 numbers we can multiply together to get 1. You give me any number, give me the number pi, I'll multiply by 1 over pi. That equals 1. So in symbolic notation we have A times 1 over A equals 1. And notice when I use the inverse property I always end up with that identity element back again. On the next page there's an example. Example 1, it has several parts. It gives you examples of properties and asks you to name the property being illustrated. Please try those right now. Pause the video. Let's see how you do on the properties. Here are the answers. A, commutative property of addition. B, commutative property of multiplication. C, associative property of addition. D, identity property of addition. E, zero property of multiplication. F, inverse property of multiplication. G, associative property of multiplication. H, commutative property of multiplication. I, symmetric property. J, reflexive property. K, transitive property, or you could also say the substitution property. L, substitution property. For example 2, we have a proof. We're given 3x plus 5y equals 6 and y equals 2p. We want to prove that x equals 6 minus 10p, all divided by 3. Take a moment to try this proof. Let's see how well you can do using all of the properties that you've learned so far. Keep in mind that there's often more than one way you can complete a proof. Here's the approach that I took to this one. Notice I began by writing my given information. I then used that y equals 2p and completed a substitution to give me 3x plus 5 times 2p equals 6. That's the substitution property. Then I took the 5 times the 2, that gave me 10p. So I have 3x plus 10p equals 6. And that multiplication I did was simply simplification. Now I'm going to solve to get x by itself. I'll begin by subtracting 10p from both sides. That's the subtraction property of equality. Then I have 3x equals 6 minus 10p. Divide both sides by 3, and I have x equals 6 minus 10p all over 3. And I've proven what I want to prove. Example 3 is another proof for you to try. I'm given 2w minus ac over g equals x. And I want to end up with w equals gx plus ac all over 2. Let's see how you do there. It looks like we want to get w alone and use our properties to justify each step. Please pause here, give that proof a try, and then let's compare yours to mine. I begin this proof by doing what I always do. I write down the given information. 2w minus ac over g equals x. And I look at what I want to prove. I want to prove that w equals gx plus ac over 2. I guess I need to get w alone. I began by multiplying both sides by g. That's the multiplication property of equality. That gives me 2w minus ac equals gx. Next, I work toward getting that w by itself by adding ac to both sides. The addition property of equality gives me 2w equals gx plus ac. Next, I decided to divide both sides by 2 to get w alone. That gives me w equals gx plus ac over 2 by the division property of equality. That's exactly what I wanted to prove, and so my proof is done.